Hello everyone. Today we are going to start our lecture number 5, grade 10, capacitor and capacitance from chapter 6, electrostatics. So I hope that all of you are doing well and doing excellent in your studies as usual. So let's begin our lecture. So capacitors, what are capacitors? Capacitors, you can see it is an electrical device that stores electrical charge, electrical energy, and it is usually being used in modern computers, in mobile phones, in different electronic devices. So capacitors are used to store energy. Which type of energy? Electrical energy in electrical and electronic circuits. Why electronic circuits? Because capacitors are used in computers. They store energy in normal use and then they gradually release this energy if there is a power failure, so that the computer will operate long enough to save valuable data. So whenever there is a shortage of supply, power supply, shortage of voltage, then we use capacitor. So here you can see this is the basic circuit diagram for the capacitor. It consists of the main components are the two conductive or metal plates, and between this plate there is insulating material, insulating media, that is which is called dielectric. You can see the overall internal structure of the capacitor, metal plates, and between these metal plates there is insulating material, and purpose of this insulating material is to store charge. So capacitors, you can see over here two metal plates, and between these two metal plates the dielectric material is being constructed. So capacitors, every capacitor has two leads, each connected to a metal plate. So there are two leads, the two wires, they are connected to a metal plates. To store energy, these two plates must be given equal and opposite electrical charge. So this electrical charge is provided through potential, through a power supply. Between the plate is an insulating material called the dielectric. You can see over here, this is the dielectric, which is an insulating material. So you can see over here the two electric metal plate are being connected through a power supply. To move charge onto the plates of the capacitor, it must be connected to a voltage supply. Voltage is supplied over here. And this voltage will provide charge to the capacitor, and the capacitor will store the charge. The negative terminal of the supply pushes electrons onto one plate, making it negatively charged. So the negative terminal of the power supply, it will provide negative charge to the negative terminal of the capacitor. Electrons are repelled from the other plate, making it positively charged. So when electron is provided from the negative terminal of the one capacitor, the other side of the capacitor will have shortage, will have lack of negative charge. So it definitely, logically, on the other side of the capacitor of the voltage supply, there would be excess of positive charge. The two emitters will give identical readings. The current stops when the potential difference across the capacitor is equal to the electromotive force of the supply. So what happens that the flow of electron will continue towards the capacitor, such that the emitter, what is emitter? Emitter is a device that measures the flow of electron. So when the emitter on both the side, the reading will become equal, then what happens? The current will stop. The current will stop when the electric motive force of the supply will become equal to the potential difference. Now here it is a potential difference. Potential difference will be provided here. And what is electromotive force? Electromotive force is the force which is required for a charge to move throughout the electrical circuit. So when this potential difference becomes equal to the electromotive force, then we can say that the capacitor has gained full charge. Now, what is capacitance? Capacitance can be defined as the ratio of the magnitude of the charge on either conductor to the potential difference between the conductor, or we can say that the capacitance of a capacitor is the charge stored on one plate per unit of potential difference between the plates. So, mathematically we can write capacitance is the ratio of the charge provided by the potential difference. Formula is C is equal to Q over change in potential difference. The charge on the capacitor may be calculated using the capacitance. Use this equation we can also find the charge. So Q is equal to the product of potential difference and capacitance. This equation shows that the charge depends on two things, that is capacitance and the voltage. Which means that if we double the voltage, we will have double charge being stored in the capacitor. The unit of capacitance is Faraday. So 1 Faraday is equal to 1 coulomb per voltage. In practice, a Faraday is a very large unit. So few capacitors have a capacitor of 1 Faraday. So there are few capacitors which is being used in mega computers that have there in mega computers the circuits. In circuits where capacitors are being used, they have charge in Faraday. But normally in electronic devices, the capacitors which are being used, they are normally of the value of picofarads, nanofarads, or microfarads. So these are small capacitor having small storage capacity. So picofaraday is equal to 10 raised to minus 12 Faraday. Pico means 10 raised to power minus 12. Nano means 10 raised to power minus 9. Nanofaraday means 10 raised to power minus 9 Faraday. And micro is 10 raised to power minus 6 Faraday. So you need to memorize this unit because in coming slides we are going to solve question, and we have to know the interconversion of these units. So question number 1 is a metal sphere mounted on an insulating rod carries a charge of 6 nanocoulomb, means 6 into 10 raised to power minus 9 coulomb, when its potential is 200 volt higher than its surrounding. What is the capacitance of the capacitor formed by the sphere and its surrounding? So here the given data is charge. Given charge is 6 nanocoulomb. 6 nanocoulomb is equal to 6 into 10 raised to power minus 9 coulomb. And voltage is 200 voltage. So we need to find the capacitance. So the formula of capacitance is ratio of charge over voltage. Putting the value in this equation, we get the value of capacitance to be 30 picofarad. Question number 2 is, what is the change on a 300 picofarad capacitor when it is charged to a voltage of 1 kilovolt? So here the capacitance is 300 picofarad, which is, we know that pico is 10 raised to power minus 12. So we need to multiply 10 raised to power minus 12 with 300. And voltage is 1 kilovolt or 1000 volt. So we need to find the charge. So we know that the charge is equal to the product of voltage and capacitance. Putting the value in the equation, we get the final value to be 0.3 microcoulomb. Question number 3. Calculate the charge on a 220 microfarad capacitor charged up to 15 volt. Give your answer in microcoulomb and in coulombs. Now here the given data is that of capacitance, that is 220 microfarad. And we know that micro is very small unit, that is 10 raised to power minus 6 Faraday. And given voltage is 15, so we need to find the charge. We know that the charge is the product of voltage and capacitance. Putting the value in the equation, we get the charge to be 3300 into 10 raised to power minus 3 coulomb or 3.3 microcoulomb. Question number 4. A charge of 1.0 into 10 raised to power minus 3 coulomb is measured on a capacitor with a potential difference across it of 500 volt. Calculate the capacitance in farads and microfarad. So here we know that the given charge is 1.0 into 10 raised to power minus 3 coulomb or 1 microcoulomb. and voltage is 500 volt. We need to find the capacitance. So we know that capacitance is the ratio of charge over voltage. Putting the value in this equation, we get the capacitance to be 0.002 into 10 to the power minus 3 Faraday, or 2 into 10 to the power minus 6 Faraday, or 2 microfarad. Question number 5. A parallel plate capacitor of capacitance 5 microfarad carries a charge of 30 microcoulomb. What is the potential difference between the plates of the Faraday? So we need to find the potential difference, that is voltage. We need to find the voltage. So here capacitance is given, that is 5 microfarad, and we know that micro is 10 raised to the power minus 6. So we need to multiply 10 raised to the power minus 6 with 5. And given charge is 30 microcoulomb. We need to multiply 30 with 10 raised to the power minus 6. So we need to find the potential difference. So potential difference is equal to charge over capacitance. Putting the value in the equation, we get voltage to be 6 volt. So I hope that you have understood the lecture. Stay happy and take care of yourself.